here's a situation where we have two lines. We're going to write the equation of each line. Starting with the blue line, we have a y-intercept of 0, 5, and we have a slope of rise of 1 and a run of 3, both being positive. So a slope of 1/3. So the equation of the blue line is y equals 1/3 x plus 5. The equation of the red line has a y-intercept of 0, -5, and has a slope of -3 over +1. Or just -3. So y equals -3x minus 5. Now, we're going to solve the system algebraically. Before we do, let's see what our solution should become if we solve it algebraically. And we talked about this earlier this week, that when two lines intersect, they have this common point. And this point where they intersect is considered a solution to the two lines because it's a common point to both lines. So for this system, it is at -3, +4. So we want to see if when we solve this, if we get +3 or -3, +4 when we solve it. Now, something I know is that 4 is in common. The y value is the same for both of these. So if the y is going to be the same, y equals 1/3 x plus 5, y equals -3x minus 5, what I'm going to do is I'm going to set the 1/3 x plus 5 equal to the -3x minus 5 because both of those expressions equal y. So 1/3 x plus 5 equals -3x minus 5. And then I know you're looking at this and you're like, oh, Mrs. Scarpel, do we really have to do a problem with a fraction? And I'm going to teach you something here. If you really don't like the fraction, you can multiply by the least common denominator. Well, I only have one denominator, and that's a 3. So we can take everything in this equation, everything in the equation times 3. And you will have an equivalent equation. When I take 3 times 1/3, that's like saying 1/3 of 3. So 3 times 1/3, I take 3 times 1 is 3 and divide it by 3 is 1. So I'm going to have 1x plus 3 times 5 is 15 equals 3 times -3x is -9x. 3 times -5 is -15. And now you have an equation that doesn't have fractions and you can solve it. Another recommendation I'm going to make is, through that equal sign, divide your equation into two sides so that we can keep it balanced, so that what you do to one side of the equation, you're also doing to the other side to keep it balanced. I like to have my x terms, or get x on one side of the equation, and I like to keep it positive if I can. So I'm going to add 9x to each side, And we will end up with 10x plus 15 equals negative 15. So I've kept it balanced so far because I added 9x to each side. Then I'm going to subtract 15 from both sides. And I will have 10x equals negative 30. And then I can divide both sides by 10. And I will end up with x equals negative 3, which is what I want to have happen because my point of intersection is at negative 3, 4. But now I need to solve for y. So now that I know what x is, I need to plug it in or substitute it into one of these two equations to solve for y. I'm going to go ahead and use the equation of the red line just because there isn't any fraction in it. So to find y, I'm going to use the red line, and I'm going to substitute the negative 3 that we found for x in for the x, and simplify the right-hand side of that equation. So negative 3 times negative 3 is a positive 9. Subtract 5, and 9 subtract 5 is 4. And we wanted y to be 4. So we did find that the solution to this system algebraically is 3, 4, just like we see it on the graph. The point that is shared by the two lines is negative 3, 4. So next week we will be looking at solving some systems algebraically, and it's just taking what we've seen on the graph and what we've been comparing with that point that the two lines share, and how can we now do it without having to graph the line or have the line. So that's what we're going to be looking at next week.